What is up YouTube? Welcome back to another episode on Code with Annie. And in this episode, we're going to take a look at the map data structure. Now map is, as already mentioned, right, is not part of collections framework, but if you look at the collection set, the implementations of set internally use a map or a hash map specifically for certain sets like hash sets, and for other sets like linked hash set, they use linked hash map. So all of them do have a variant of map being implemented behind the scenes, although technically map is not part of collections because it doesn't implement the collections interface directly or indirectly. So let's talk about this unique data structure called map. So map basically is a combination of two data types, right? It has an integer or a string or boolean or any data type key, comma any data type value. So let's create a very simple map of integer key and string value. Okay, map is equal to new. Let's create the very basic implementation of map, which is hash map. So there are two more variants of map which I'm going to talk about in this video. One of them is linked hash map and the other one is tree map. Okay, so a hash map is the very generic implementation you'll find in most of your real world programming code, wherever you're working or and whenever you're trying to solve problems over lead code or any other website. You will find mostly the use of hash map. Okay, in very certain scenarios you will be ending up using the linked hash map and tree map. Now let's take a look at how we can add elements to a map. Let's say a map dot. If you see the methods that are present here, right, you have a barrage of methods present for map data structure, right? Contains key, contains value, entry set, okay, is empty, key set, merge, put all, put if absent, remove, right? So put is the very fundamental method which will allow you to put a key, comma, value. I'm going to say that ONE1 probably. Okay. Likewise, I can add two more elements to the map, 2, 2 and 3, 3. So the one key property of map is all the keys in the map should always be unique. If you try to add a duplicate key in the map with some value, it will override the already present key with the new value that you try to insert. Okay, it will not put another entry, it will rather just override the existing value. So we have put 3 elements to the map. Let's try to iterate and see what are there in the map, right? Map dot I can say map dot entry set. This is one method which basically gives you a set of entry integer comma value. I'll show you how this works. Map dot entry set dot for each, okay, entry implies entry dot get key and entry dot get value. So it iterates over this map and it creates a set of tuples. These are called tuples. So key comma value in combination is called as a tuple. So 1, 1, 2, 2, 3, 3. So it creates a set of all these tuples put together, and that's what we call as an entry in a entry set. So if you look at the definition of entry set here, right, it's a set of map dot entry integer comma string entry set. Okay, so it's going to be a combination of key comma value. So I'm going to say entry dot get value, entry dot get key and get value. Okay, entry dot get key, and I'm just going to try to print it out, right, because it's a for each. Let's try to print out the values. Okay, entry dot get key. So I will just say key colon entry dot get key plus space value colon entry dot get value. Okay, just try to print this out, and it is giving some suggestions to us. Let's see, it's print line here, and I think it wants us to close this one for the error. It says that we can replace it with a string template. I'll teach about the templates later. And for each loop can, I think we replaced with map dot for each, right? Instead of saying a map dot entry set dot for each, you can simply say a map dot for each, and it is understood that key comma value, whatever is the key, what is the value, you can print out. Let's try to run this one and see what is the result. Now we're building the project. Let's wait for it to build. And the first build usually takes time in IntelliJ, but subsequently it will become faster. because it have cached the build properties, right? Now we have key 1 value 1, key 2 value 2, and key 3 value 3, which is exactly what we tried to print out here. Okay, now what I'm going to do is I'm going to tell you some more interesting concepts with respect to map. So in a map, just like other data structures that we have seen so far, right, you can put all, meaning you can put an entirely different map into another map. Okay, like put all basically is a map which can hold another map completely, map of maps, or I mean put all the maps together in one map. Let's show you what it does is inside this method, and it says that okay, it's a bulk operation, meaning copies all the mappings from the specified map to this particular map. So you have, let's say, multiple map entries, right, different maps, and you can put all of them together into one particular map. So map is a combination key value pair, right? So if you have another map which is having different key value pairs, you can directly put that into this particular map. So all of the key values will be copied into this particular map. Okay, that is put all. Likewise, you have other methods like clear, which will just clear the map completely. Contains key basically checks if a particular key is there. So if say contains key of 1, it will say true because 1 is there in the map. Contains key of 4 will be false. Likewise, you can have contains value as well. So both of them will return you a boolean indicating whether the key or the value is present in the map or not. Okay, likewise, you have other methods like hash code, isEmpty. isEmpty basically will check whether the map is empty or not. I'll talk about the hash code and equals in a different video in more detail, so stay tuned for that. Key set is basically a set of only the keys in the map. It will not consider the values. It will just take the keys out of the map and it will give you a set of the keys. That is very useful if you want to just operate on the keys. So it's a set of integer. Merge basically will merge two maps. I think, let me check that. Okay, so it is saying that it associates with the given non, otherwise replaces the associated value the results of the remapping function. If the remapping function returns null, the mapping is removed. If the remapping function throws unchecked exception, it is thrown. Okay. So it's saying old value, new value, and if you're saying map.merge, what it does is default implementing guarantees no method of synchronization or atomicity. I'll talk about synchronization and concurrency in a different video, because there's going to be something called concurrent map, which is very useful for performing concurrent operations. So merge is basically just going to merge the old value and the new value of the key present in the map. Okay, and likewise there will be many methods. I want you guys to explore it by yourself, as in when a requirement arises for you guys to use that particular method. So in this video, we're going to take a look at the other two maps implementations as well. One is called as linked hash map. So let me create a linked hash map and a tree map as well. Okay, a linked hash map. Okay, equal to linked hash map. As I've already mentioned in the linked hash set, right? Linked hash map is a very similar implementation, meaning it uses a doubly linked list backing, which means it will have the preservation of insertion order, just like set, right? Set does not guarantee that the insertion that you do into the set is always preserved in the same order, but linked hash map, just same way, hash map will not also guarantee the entry that you put here will always be the same how it is stored inside. Okay, it may change when you try to print out the elements. Right now it is printing the exact order we inserted, but if you try to print over 100 or 1000 times, it might print out in a different order. So if you want to retain that insertion order, you have to use a linked hash map. Okay, likewise, there is something called as tree map, very similar to tree set. A tree map is also a particular implementation which will make sure that whatever you put into the map, by default it will have it in a sorted order. Okay, you can have a custom comparator, just like I showed you in a priority queue video, right? You can use a custom comparator to make sure the sorting happens according to what you want. Otherwise, it will just retain the ascending order of sorting. Okay, whatever you put into the map will always be sorted. Okay, if you want to test out how these two perform, let's try to do the same thing in linked hash map and tree map. Okay, I'm just going to say linked hash map. Let's try to put that here, 1, 2, 3, and same thing let's try to put with the tree map. Okay, I'm going to say tree map dot put. Okay, now let's try to print out both of these one by one. Linked hash map dot for each. Okay, and tree map dot for each. Okay, but for tree map, I'm just going to change the order just to show you that the order is different. I'm here saying 3 to 1, it should be 1 2 3. Okay, 1 2 3. So 1 should be printed first, 2 should be next, 3 should be the third one in a tree map. For linked hash map, it should be fine. I'm just going to just replace this with 2 and 2 1 3, and it should always be 2 1 3. Okay, now let's run this and see what is the outcome of this execution. And here we go, we have the result here, right? So the first one is a linked hash map that we are printing out, correct, if I'm not wrong? Yeah, so its value is 213, and that's what it printed out. Next one is tree map. Now see, it has sorted it according to the key. So key was 1 2 3, it has sorted them according to the key. So by default it will sort through the key, and if you want a custom sorting based on value or anything else, you can probably use a comparator like I showed you guys in the priority key video. If you haven't seen that, do have a watch at that, because that will help you give a very important concept of how you can use custom comparators, and you can apply a similar comparator to the tree map as well. As you could have guessed, hash map is the one that backs the hash set, linked hash map backs the linked hash set, and tree map will back your tree set. Okay, so that's it for this video on map and the different implementations. I hope this video is quite helpful. There are several methods, so don't take me wrong if I have not explored all of the methods of the map. Please do take a look. If you have any doubts, do hit the like button, subscribe, and then put your comments there. Just kidding. You can simply put the comments there as well. I'll take a look at it and I'll reply as much to my knowledge as I can. And I hope to see you guys in the next video. Share this with your friends. And for now, bye guys.